Welcome back, science fans. We've discussed some cool topics, from robot aliens to what happens if an asteroid smashes into the Earth. But let's talk about a major problem for humanity right now, and that's that life exists only on Earth. If global warming makes our planet look like Venus's hellscape or some other terrible catastrophe hits us, we have nowhere to go. But what if there was another planet out there in case something happened to ours? Well, let's consider that. Living on Mars is one of the most exciting ideas in human history. But we would only be able to live there if we terraform the planet, which means converting its environment to make it habitable for humans. You may think that only happens in sci-fi movies, but it's a real idea that brilliant people are talking about. In this video, we'll explore how to terraform Mars and 3 big ways it will change life as we know it. If you like this channel, please subscribe. That's the best way to build it and get it in front of more people. Assume you took a rocket to Mars, landed it on the red rocky world, and stepped outside. At first it may feel perfect, like an early summer day in New England. The temperature could be as warm as 70 degrees Fahrenheit at the equator, but immediately you would realize you couldn't breathe, because the air is mostly carbon dioxide. Also, the planet's thin atmosphere does not provide enough protection from harmful solar radiation, so to survive, humans would need to wear protective gear at all times. And come on. That's no fun. Terraforming Mars would be really difficult, but it is scientifically possible. So how would we do it? Through science, of course. It would involve several stages. First, you would have to thicken the atmosphere and make it warmer. Mars has polar ice caps made of water and carbon dioxide. Melting the ice caps could release water vapor into the atmosphere, thickening and warming the planet. An approach to melt them could be to place giant mirrors around the planet that reflect sunlight onto the surface. This would increase the temperature and could help thaw the ice caps. Second, we would need to create a magnetic field to protect life from solar radiation. An option for this is to place a giant magnet at the planet's L1 Lagrange point, which is the point where the Sun's and Mars's gravity cancel each other out. Finally, once the atmosphere is stable, an ecosystem could be created. This would involve introducing plants and bacteria that use photosynthesis to produce oxygen and convert carbon dioxide into breathable air. Over time, as the ecosystem develops, it could support more complex life forms. This would take hundreds of years, but Mars could transform into a sustainable human environment. It sounds easy, but to do that on a planetary scale is challenging. Humans will have to develop creative solutions to problems never encountered before. As I mentioned earlier, the most immediate hardship we'll face is being unable to breathe the air since it's mostly carbon dioxide. Mars doesn't have enough oxygen, but large-scale atmospheric processing could solve this problem. Atmospheric processing would require a lot of innovation. To start, scientists must design and build giant machines that can extract gases from the environment and release them into the atmosphere. Imagine standing on a rocky outcrop on Mars and watching a smaller sun as it slowly sets behind a red horizon. In front of you is a towering machine with many large chambers. In the first chamber, carbon dioxide is piped in from the atmosphere and collected and pushed through electrolysis, a process that separates the carbon and oxygen atoms. Next, the separated oxygen is combined with other gases in a final chamber to create a breathable atmosphere. It sounds easy, but to do that on a planetary scale is challenging. Advanced robotics will play a crucial role in the terraforming of Mars. Mining, construction, and transportation on Mars will require sophisticated machinery that can operate in harsh conditions. These machines must be designed to operate autonomously and use artificial intelligence to make decisions on their own. Unfortunately, in the early stages of terraforming, there won't be many engineers or specialists around to help. So instead, the machines will be equipped with advanced sensors and cameras to gather data about the planet's environment and operate independently as much as possible. Terraforming Mars can be the first step towards exploring other planets and moons in our solar system. The technology gained from this work could be applied to other celestial bodies, leading to discoveries of new worlds that we previously thought were uninhabitable. For example, the moons around Jupiter and Saturn, such as Europa, Enceladus, and Titan, have subsurface oceans that could be explored. Once we terraform Mars, we can leverage that technology to search for alien life in the oceans of those moons. Furthermore, because of the vast distances of space, we must develop advanced propulsion systems for interplanetary travel, such as plasma engines, ion drives, or fusion engines. These new engines will be necessary for rapid travel between Earth and Mars. In addition, the technologies would significantly increase the payload capacity of spacecraft and enable more extensive and complex missions. While these improvements would benefit us for Mars, they could also be used for other space missions, including deep space exploration and asteroid mining. With humans living on Mars, new communication technologies must be developed to ensure that messages are transmitted quickly between Earth and Mars. For example, a message now takes up to 22 minutes to travel between both worlds. Could you imagine saying, "We need help on Mars," and waiting 20 minutes for an answer? So scientists are looking at new options, such as the Deep Space Optical Communications System, which uses lasers to transmit data between the planets much faster than traditional radio communications. Terraforming Mars would also establish a permanent base on the planet, providing a launching point to further explore other worlds. The discoveries made during these missions could also expand our understanding of the universe and the potential for life beyond Earth. Throughout history, humans have ventured into unknown lands and territories, pushing the boundaries of what we thought was possible. From the first nomadic tribes through the Middle Ages, we have always sought to discover new lands. Then, as society advanced, we built large, ocean-going ships to navigate the seas and explore new continents and oceans. From Columbus's discovery of the New World to Magellan's circumnavigation of the globe, humans have sought to push the boundaries of what is possible. But Mars isn't Earth. Although it's relatively close and is the fourth planet from the Sun, the vast distances of space mean it's truly a new frontier for exploration. The psychological impact of living on Mars, a hostile and unfamiliar planet, would be a significant challenge for the first settlers. They would be isolated from Earth and their loved ones, and the dangers associated with living on a new planet could be frightening. They would face a vastly different environment and set of challenges than the first settlers of America. For example, they would arrive on a barren planet without the benefit of interacting with existing societies or trading with neighboring communities as the first settlers of North America did. The harsh conditions, lack of oxygen, and extreme temperatures are much more severe than anything the Pilgrims experienced. But like the great explorers of the past, the colonists who venture to Mars will be driven by a spirit of adventure and discovery. Terraforming and living on Mars would likely lead to significant changes for humanity, especially over time. If we were to live on Mars for thousands of years, we would probably undergo significant physical adaptations to better suit us to the demanding Martian environment. For example, due to the lower gravity on Mars compared to Earth, humans may gradually become taller and thinner over many generations to better cope with the reduced gravitational force. Humans would also develop larger lung capacity and more efficient respiratory systems to better extract oxygen from the thin Martian air. This would happen because oxygen concentration will not reach Earth's level. After all, Mars lacks a magnetic field to protect it from the solar wind, which will slowly strip away atmospheric gases. A man-made magnet around Mars will never be as good as the Earth's core, which creates a very strong magnetic field. Other possible adaptations include an improved vision to better see in the dimmer Martian light, enhanced muscle strength to navigate the rocky terrain, and increased intelligence to efficiently solve the unique challenges of living on a new planet. Over time, these physical adaptations could result in a population on Mars that is pretty different from the humans on Earth. Over thousands of years, we would transform into Martians. So now you know how terraforming Mars could change humanity forever. But did you know that something amazing is coming much sooner than our ability to terraform Mars? Click on my next video to learn how artificial intelligence is advancing faster than expected, and how it will change society more than we dream possible.